Hello friends, today I'll discuss about in distance relay how the impedance conversion is done from primary to secondary value. Distance relay is used as the main protection from the transmission line. If fault occur within the protected zone, then distance relay will pick up as per the zone setting and relay will sense this fault from the CT and PT secondary input which is given to the relay, and it sends the fault if within this zone, then it will send a trip signal to circuit breaker to isolate this fault. So different zone is setting is given to the distance relay. For example, zone 1 is given as the 80% of the protective line length, zone 2 is given as the 120% of the protective line length, and zone 3 is given as the 100 which covers the protective line length and next longest line length, that is the 120% of the protective line length plus next longest line length in order to avoid underreaching. So this is the general philosophy for protection of the distance relay. So in this video I'll discuss how the impedance conversion is done from primary to secondary value for distance relay. So in case of distance relay uh, calculate the impedance based on the CT secondary input and PT secondary voltage input which is given to the relay. So fault occur in the transmission line. This fault during the fault, the current will increase and voltage will decrease. So the primary impedance is equal to voltage divided by current. The Z will decrease and it will fall into the zone, which is zone setting, which is given to the distance relay. But relay sends this based on the PT secondary input and CT secondary current. So ZS is the secondary impedance. So ZS is calculated based on the PT secondary voltage input and CT secondary current input. So ZS is equal to PT secondary voltage divided by CT secondary current. Now ZP is the primary value of the impedance during the fault. So ZP is the PT primary voltage divided by CT primary current. So this is how the conversion is done. So ZS by ZP is equal to CT primary divided by CT secondary current divided by PT primary divided by PT secondary voltage. So we can calculate the CT impedance in terms of secondary value, that is ZS equal to CT ratio by PT ratio into ZP. So whatever value of the ZP, if we multiply the factor CT ratio by PT ratio, we can get the value of the secondary impedance which is sensed by the distance relay. So this is how the conversion is done from primary to secondary value. Now let us take a simple example for a transmission line of Panther conductor of 132 kV double circuit line. So for 132 kV double circuit single Panther, the value of the positive sequence resistance and positive sequence reactance is 0.14 ohm per kilometer and 0.4010 ohm per kilometer. So this is the value of the positive sequence resistance and positive sequence reactance as per ohm per kilometer in primary value. So the value of the primary impedance, that is the ZP is equal to 0.4247 at an angle 70.74, which is nothing but root over of R1 square plus X1 square, which comes as 0.4247 at an angle 70.75 ohm per kilometer. So per kilometer, the value of the impedance in terms of the primary value is 0.4247. Now for zone 1 setting is given as the 80% of the protective line length. Now let us consider that protective line length is 100 kilometer. So we can calculate this zone 1 setting based on the primary value, that is the 80% of the 100 kilometer line, and the value of the impedance as per ohm per kilometer is 0.4247. So we will get the value of the Z1P is equal to 33.976 ohm. So this is the value of the primary impedance for zone 1 value. Now zone 1 secondary. So in order to get the value of the secondary value, we have to multiply it by the factor CT ratio by PT ratio. Now let us consider that CT ratio is 600 by 1 and it is a 132 kV line, and PT ratio is 132 kV by 110, which is nothing but 1200. Okay, so the factor is 600 by 1200, it is equal to 0.5. So if you multiply the primary value of Z1P and by multiplying factor 0.5, we will get the value of the Z1S, that is the value of the secondary value. So Z1S is equal to 33.976 into 0.5 is equal to 16.988 ohm. So this is how the secondary impedance conversion is done from the primary value of the impedance. So friends, if you like my video, then please go through my channel and do subscribe my channel, and also press bell button for notification of videos to be uploaded in future. Thank you for watching this video.